thousands of years, we humans have gazed up at the sky and wondered. Look for messages. Look for keys to deeper understanding. But perhaps the cosmos is laughing. Do we really see the universe as it is, or as we thought it should be?
Throughout the space age, astonishment and surprise have been the hallmark of scientific progress. Everywhere we've looked, whether close to Earth or in remote space, we've uncovered things forbidden by our theories. What we expected to find, we've not found, and things beyond all expectation have become commonplace. In science, a surprise is always good news. It prods us to see things differently, to ask more pointed questions. One discovery in space inspires another, and beneath it all today is the encounter with the one thing our theories didn't allow: intense electromagnetism. Electrical and magnetic energies in the vacuum of space beyond anything astronomers expected. That's what has happened as astronomers, physicists, and planetary scientists have come face to face with the electric universe.
Ancient civilizations tracked the wandering bright points in the sky around our star. But where is our star moving in the galaxy? A simple answer would be, we are rotating around the center. However, a better answer is not easily found online, especially after 2011, when IBEX discovered the nose of our sun's heliosphere, the magnetic bubble around our solar system. In a critically unfortunate error, the group determined that the nose of the sun's magnetic field must be pointed in the sun's direction of motion through the galaxy, not unlike the nose of a bow shock out ahead of a ship or a supersonic jet. The problem is that isn't how electromagnetism and kinetic motion interact, and we're talking about the sun's magnetic field and its motion in the galaxy. Furthermore, the center of the galaxy is in Sagittarius, towards Scorpio, and indeed, it makes sense that the galactic version of the solar wind is coming from near the center of the galaxy, so the nose of the magnetic field makes sense. But is the sun moving towards the center of the galaxy too, or are we moving around it? This clearly doesn't make sense outside of the magnetic nose, which absolutely should point at where the galactic wind is coming from. But we're not falling into the center of the galaxy, we're rotating around it. And just like the Earth, where the nose of our magnetosphere points at the sun, but we don't move towards the sun, we move around it. We see the same in the ionic and electromagnetic comet interaction. The nose and tail that stream opposite in a way don't point on the line it travels, it points aligned with the electromagnetic power.
On December 15, 2011, NASA's Solar Dynamics Observatory captured this footage of Comet Lovejoy approaching the Sun. An hour later, it watched as Lovejoy came around the far side of the Sun and began its long trip back to the outer reaches of the solar system. Other NASA spacecraft, such as SOHO and Stereo, also saw Lovejoy's close encounter. Lovejoy marked one of the few times that orbiting telescopes have been able to watch a so-called sun-grazing comet survive its trip around the Sun. Most are not so lucky.
Comet tails, with their ionized gases, are affected by magnetic fields, and so they can act as brief tracers. On April 20th, 2007, Comet Encke had its tail stripped off abruptly by
a coronal mass ejection that carried a strong parcel of magnetic field through the solar system. Even closer to the Sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the Sun.
comets interact with the solar wind, the sun interacts with the wind amidst the stars and points in that direction. But it's the magnetism, not the direction it's moving. So let's refocus back on something that might help us out. Let's try to use what we do know about where we should be looking ahead in our rotational pathway to figure out where in the sky we might want to look if we want to just go outside and take a peek at the stars. It will be critical to understand that if we are looking at the center of the galaxy and our line of sight in bottom right there in the corner, we basically have to come all the way over about 60 degrees or more to see our general pathway. Now, it was just 1 year later that this graphic was released by NASA. Now, I've zoomed in to show some detail, but what I cut off was the indicator that the center of the galaxy is directly off to the right. The yellow arrow makes much more sense now if indeed our rotation is around the galaxy in that way. And there is one other important thing in NASA's 2012 graphic that can be very helpful. Alpha Centauri down there and slightly to the right. If you can use some spatial reconfiguring inside your head to consider how this would look from the sun's point of view, if the sun is looking directly at the center of the galaxy, the Alpha Centauri system should be off to the right as we are moving generally to the left. We already know the center of the galaxy is in Sagittarius, and the Alpha Centauri system happens to be found in the constellation Centaurus, sort of obvious from the name, and it actually is part of the primary constellation. So just using the basic viewer at solarsystemscope.com, Sagittarius isn't on there, but it's next to Scorpio, as you hopefully recall from a minute ago, over to the right below Mars and Centaurus, but Alpha is actually at the leg near the top of it from this perspective, so put it about there, which means we have to look to the left, and what immediately jumps out in that general direction is the water carrier, better known as Aquarius. Let's check this on a proper star map. Center of the galaxy in this area here, Sagittarius and Scorpio underlined. Just where it is supposed to be, Centaurus is over there to the right, so perhaps Aquarius was not such a bad guess. Now, in reality, we travel up and down through the galactic plane, so if you wanted a good range above and below the galactic plane of where we're heading, I'd look as far south as Aquarius and as far north as Hercules or Draco, but not much at all side to side. It is worth noting that it is believed we are above the galactic plane and actually heading a bit further north of it, which points more at the Hercules and Draco direction, perhaps Cygnus. Now, this is true in every season and will be true for thousands of years until the stars' motions in the heavens change the very appearance of the constellations themselves. So perhaps now we have a better answer to where is the sun going than a simple around the galaxy. We can peg the general direction and even some of the constellations that may be in the line. In part 2 of Where Are We Going, we will answer this question from another perspective, one that changes much more quickly and has a practical effect on our daily lives. See an updated version of the graphic from part 1, this time with the astrospheres noted. Here, the mistake we highlighted in part 1 is greatly illuminated. All the astrospheres point at the galactic center off to the right, not just our own, and it's those magnetic shields aligned with the galactic center. None of the stars is moving towards the galactic center. In fact, their trajectories are much closer to the sun's as we all go through the galaxy together. It turns out that one NASA scientist was annoyed with this general ambiguity a few years ago and posted this image online. It is not showing much different from the previous image, except that he went ahead and labeled the star at which we are heading, and it's Altair. You remember Altair.
Quiet, please. I am analyzing.
Yes, that one. And if you don't know where it is, the big clue was that I was circling it in this portion of the video from part 1. Altair completes the Aquila constellation's head in the southern end of the Summer Triangle with the Cygnus constellation and Vega and Lyra. Yesterday's direction field guess circle is now annotated with the position of Altair. We can sufficiently consider the direction of motion corrected and understood. Now, back to the arm of the galaxy. There is a massive void in local space known as the local bubble, the remnant shell of numerous supernovae, with the core remaining as the local interstellar cloud through which we are indeed currently moving. Now, while the supernova void is tremendously sparse, its neutral helium content is the primary source of the X-ray background of the sky, and the local cloud here at the core around our sun is 6 times more dense in hydrogen, and is confirmed to be strongly magnetized. It also has a wide array of other elements as well. We are in a supernova remnant after all, and we should consider the oxygen to neon ratios, relatively similar to other sources, to be a pretty good indicator of the general elemental abundances. It is expressly believed by some at NASA that there is even more oxygen there locked up in the rocks and dust of the cloud, like iron oxide or aluminum oxide, as is much of the oxygen inside of our Earth, which is the mantle's most abundant element, by the way, just in rock form, not the gas we are used to breathing. It is interesting to note that it was the same interstellar or galactic wind that originally misguided some to believe we were heading towards the center of the galaxy that eventually showed our position. It was based on that galactic wind that they published this alongside the cloud image, the chart showing how the older results hinted at our being in the void amidst the empty areas of the interstellar cloud, but how newer data, based on that galactic wind, caused us to now know that we are indeed inside of the local cloud. But that is about to change. You see, while the sun has been on a steady trajectory, the cloud is moving in another direction, to the left. So the sun is more likely to have entered the cloud at where the red arrow is pointing, that portion of the cloud there, but did so many years ago when that portion of the cloud was back over to the right, such that the red and yellow arrows would have been on top of one another. This combined relative motion analysis means we are moving pretty much directly into an empty area within some of the remaining nova core clouds, out of the denser magnetized shroud cocooning our solar system, and literally into the void. In Part 3, we will examine what this might mean for the future of our solar system and our planet. We use what we have learned to begin answering the question in a more practical way. For example, we are going to the store is one use of the word. We are going to have a rough road ahead is another perfectly valid use. Here, we aim to frame the bigger picture of where the solar system is actually moving, combined with known natural events concurrently ongoing, and determine the number one effect of their combination. First, let's warm up with a much more macro-scale view. Forget where we're going in the galaxy, let's look at galaxy clusters across the known universe. A group of scientists a few years ago began tracking and mapping the cosmos in a different way. They didn't want to know just where galaxy clusters were, but where they had been, and more importantly, where they are going. When they mapped the velocity profiles and where things are heading, they came up with a trail-based diagram that shows the general motion towards the Great Attractor, a superstructure known as Laniakea there, which has a sister group called the Perseus-Pisces cluster. We are roughly in the middle, moving towards the Great Attractor, but it turns out that in 2017 their next release would reveal an even larger dipole structure with an even greater attractive cluster behind the Great Attractor, making the Great Attractor just the keyhole we are going through towards the big show. Indeed, there is a strange trend of the entire known universe from one point towards another. Not that this is precisely useful in your daily life or relevant to parts 1 and 2, but if you are getting yourself squared up with the cosmos and your place inside of it, might as well step back as well. Now, let's come back into our solar system in the galaxy. We are in the process of coming out of a dense, magnetized cloud of 50 to 200% stronger magnetic field than would be expected in the interstellar medium. 17 years ago, it was determined that our total entry and exit timeline was around 50,000 years, with us having about 10,000 years left. Not a bad guess, but those numbers were not updated with the 2012 release you see here, and clearly we don't have 20% of the way left to go. We're right on the verge of our exodus from the cloud now. In fact, it is likely most accurate to say we are coming out of it more and more every single day, and that will be true for at least the rest of our lifetimes. So as we exit the cloud, a magnetized bubble, we are entering the larger bubble, the one 6 times less dense than the local cloud out of which we are moving. It was carved out by numerous supernovae, which blasted out most of the material within light years of our star, creating the local bubble with only sparse remnants inside. We know our bubble is the result of numerous events because it has multiple lobes, including one much harder to see off the top and behind. With the expanding shell long dispersed, our solar system will be left open in this bubble outside of that magnetized cloud where cosmic rays and electromagnetic radiation like X-rays and gamma rays will more easily penetrate to reach the sun's magnetic bubble. Compounding this increase in exposure is the fact that our sun's magnetic protective bubble is dropping in strength, and that is expected to continue as well. This allows more entry of those waves and particles on top of that allowed by our exodus from the cloud in the first place. Now, the sun has been very strong recently, stronger than it has been in about 11,000 years. This has provided a large amount of protection for the last century or so, but all evidence suggests that it is about to drop out hard in the coming decades, with a lackluster return over the coming centuries that is almost certain to miss the mark set by the recent multi-millennium maximum. And the cosmic ray forecast based on that drop in solar activity alone presents uncharted territory in modern science. So to review, we are right now coming out of the grand solar maximum since the end of the glacial period. We are about to see a tremendous drop into grand solar minimum, followed by a very slow magnetic recovery that won't likely reach those same maximum levels for thousands of years, allowing for that uncharted territory of high cosmic ray flux. Now, as if uncharted territory in cosmic rays wasn't enough, and with us already leaving the larger magnetic cloud of protection, there is still one more magnetic shield to discuss. Our own, the magnetosphere of Earth. It protects our planet from the sun and those galactic and extragalactic sources of energy. Important note, it was recently discovered that the most powerful cosmic rays actually come from outside the Milky Way. But back to Earth. As the lithospheric emergence points for Earth's field, the magnetic poles tell us a lot about what is happening. They are supposed to wander a bit, but the south has wandered straight out of Antarctica, and the north is on a tear across the Arctic Ocean, dwarfing hundreds of years of movement in just the last few decades. This, concurrent with the weakening of Earth's magnetic field, sets a future of magnetic reversal for our planet. Our field peaked in strength 3,000 years ago, well inside the cloud. Its current decrease can be traced to around 1600 AD. Our magnetism began dropping at a higher rate in the 1800s, and in 2000, NASA noted we'd lost 10% of the field compared to the 1800s. ESA updated that to 15% as of their 2010 findings. That's 10% lost over more than a century, and then an acceleration to hit that same 10% loss in only 20 years. Those are scary numbers, and you don't need to be a mathematician to understand how fast of an acceleration that is. Earth, Sun, and local cloud all provide a magnetic bubble, and each is in the process of becoming less of a protective factor for our Earth. Those energetic sources from the galaxy and beyond will get an easier run through all three primary magnetic shields into the atmosphere, and we already know cosmic rays reach the ground and penetrate already. One could even argue that our being north of the galactic plane, heading further north and up, brings us out of the larger arms shielding and more exposed to the rest of the universe outside the galaxy, and I really don't know if there is any way to argue against that. But I will say that scientists understanding our being up and going higher from the galactic plane came after this notation indicating we were sort of moving at Altair. So let's go ahead and take that further constraint from part 2 and move the X just slightly to the right. Altair would still be the primary thing we're heading at there. We're well within the common sense direction ring, and we now comport with the position of our solar system relative to the galactic plane, and are not in conflict with any known science. So let's review. Earth's weaker magnetic field is going to let in more of everything that comes by: sun, galaxy, and those far away. A weaker sun means less magnetic protection from the rest of the galaxy, and again, those far away. And as we come out of this local cloud, a large magnetic cocoon, that leaves us with the fall of 3 major protective magnetic shields for our planet. Now,
Who likes whipped cream?
okay, so not to ruin this rosy masterpiece of universal attrition, but there is one other aspect of this that would be worth consideration at very least. Remember what the cloud is: magnetic hydrogen. There's also a lot of oxygen in there, both in gas form and likely trapped in the rock, where well-understood charge exchange mechanisms have demonstrated the extraction of that oxygen from the rock in asteroids of our own solar system to combine with hydrogen into water. It can certainly happen here too, and there is likely those polar water molecules aiding the magnetic character of the cloud. Now, what happens in your home, say during a humid versus dry day, or hot versus cold. You are most likely to get a static shock on a door handle when it's cold and the humidity is low. This is because there is less of a distribution and spreading out of that energy in the dry, sparse air. From the solar system scale down to Earth's magnetic field, it is difficult to tell exactly what some of the exact effects would be from entering an area of higher static potential. That would be the bubble. But somebody should probably be thinking about it.
We'll see you for part 4.
Where are we going?
A question we've answered in terms of literal motion of the solar system, philosophical metaphor, and now practical reality. We will be examining what the fall of 3 shields means for you, but like any good finale, we'll first take a look at where we've been. Macro-scale structure of the known universe, a dipole repeller at great point of attraction, with Earth and the local galaxy cluster in the middle, heading through the great attractor pathway towards the finish line of a racetrack that may be familiar in shape to the human race. Our center cluster and sister system are highly symmetric and patterned with a common destination. On the galactic scale, we are relatively close in on the arms and orbit the center of the galaxy, dipping above and below the galactic plane, generally heading towards the region of Altair, south of Vega and Cygnus now. Within our arm, we are exiting a local magnetic dust cloud, cocooning the system from the outside and into a void, the local bubble created by numerous ancient supernova, leaving us more open to the energetic events of the galaxy and greater universe. As we exit the magnetic cloud, another magnetic shield, that of our Sun, is dropping and expected to continue dropping in strength, allowing for record cosmic rays at the Earth system. As our local magnetosphere begins to fade, we are witnessing all 3 shields against space energy falling and painting an ominously energetic portrait of Earth's future. So what exactly are we talking about here? The most local events of concern would be massive solar eruptions, which we know are less common but still present in times of low activity. The only thing standing in the way of solar superstorms is our local magnetic field, and inductive explosions can cripple global power grids in a major event. Imagine no food at the store, no water from the tap, no heat or air conditioning or phone or ATM withdrawals or gas station pumps or way to call for help as the destruction and waiting we've set up across the world begins to do what they've warned us they could do when they lose power. But wait. We're getting ahead of ourselves. Before we can even think in terms like this, shouldn't we see some changes of the energetic nature on other planets? I mean, maybe if we saw record-breaking storms on Neptune at latitudes we've never seen before, or if we saw record-breaking storms on Uranus, something to say we're juicing up, or that 30-year clockwork storm on Saturn, arriving a decade early, like it did in 2010. Okay, well what about the clouds and storms on Jupiter? Surely we'd be seeing some kind of changes there as well. Mars doesn't do storms like Earth, but maybe if they were undergoing some kind of climate change. And what about Venus? Maybe if their fast winds were speeding up and getting faster or something like that. If this thing is starting to be a concern, we'll certainly see it on the other planets first. Since we mentioned storms, the ties-in of academia of late are bringing solar forcing of hurricanes and typhoons out of the darkness, with numerous publications peer-reviewed in the last decade. These complement and often rightly outshine public tracking of these connections, as has been done by thousands of members of the public online, even inspiring a middle school science project on solar-triggered cyclones that won the state and then the national science championship. To get you acquainted with the concept of Earth without protection, let's go to NASA's Dr. Kong-Papu Yen at our annual conference for laymen like you, explaining energetic effects that you might be able to apply here.
When you see solar flare, plasma, those are conductors. The real energy is surrounding that thing. For abrupt climate change, if we charge the plates with negative charge, and we simulate cloud with dry ice, you see that the cloud can be modulated using charge from above with different potential. We need to understand that it's not just charged particle hitting something for something to happen. This is called induction. It's an action at a distance, such as copper. You see it become more abrupt. And of course we see that the Earth contains ionosphere, which is highly... So anything that actually causes modulation in ionosphere translate to the ground level. To the way
electric works is that you need to bring the potential between two points of the capacitor low enough to initiate such events. such as this one, we have magnets in the bottom of the glass, and connected to a positive terminal, and they have negative terminals here. This thing is salt water, so it just helps you visualize how vortexes form. And actually, water itself is like, it behaves like plasma. So it does conduct electricity and actually like to behave like this type of things. Just like we see tornadoes, how that's formed. And this is called Thomson-Taylor theories. So this is
pretty much just summing up everything about what we see here is.
What we see here is that we see compression and expansion of layers of matters, and those layers contain charges, so you have electric field and magnetic fields going perpendicular to each other. But once there's some modulations in those layers, you start to see charge separate within the same layers. And of course, there's some kind of if charge separation here, if this plate represents the ground, the tectonic, when the stress building up on the tectonic during those times, earthquakes will occur. However, if there's high moisture contents in the atmosphere, energy has to go somewhere. So it starts to form vortex around the medium, which is called atmosphere. So you see different effects, which is tropical storm formations, more rains, cloud, like today's cloud. And of course, it becomes more of the weather effects than the earthquakes. So there are certain types and certain conditions actually building up this thing to become different type of natural disaster for a certain time. We don't do like one-to-one statistic. We have to understand the coupling mechanism and multiple cause and effects
in order to do the correct type of statistic to tell what is real and what is not real, what is random and what is coincidence. So we have to understand deep into the physics behind the mechanism, which is how I understand it. So and of course there are something happen here. The new ions form like a round circle, like electrical discharge. When you put in a welding machine, it forms like a welding spot. Same for volcanic eruptions, charge building up, and of course you see lightning.
It was recently discovered that cosmic rays increase the viscosity of silica-rich magma, which calls home many dangerous mountains on this planet. More energy of that sort should increase the activity of many of the world's volcanoes. Similar energetic interactions with the metal, water, and olivine in the mantle can trigger some of the world's worst and deadliest earthquakes and tsunamis. The specific solar triggering was discovered by Dr. Wu Yan and our community, and then confirmed by a statistics professor from Ohio State. And as our shield, the only thing standing between us and the sun, goes down, the earthquakes will be on the up as well. The cosmic rays coming from beyond the sun have been shown to juice up clouds, trigger hail nucleation, ionize and create lightning conditions, and contribute to the overall energy level of the atmosphere, and again, they penetrate through the crust. The answer to what our future holds as three shields fall at the same time is more electrical energy. The lack of density around the system dictates that more energy will be focused on the spheres that remain, and the weather, earthquakes, and volcanoes may soon resemble something out of an ancient story, like Ragnarok. There is also a growing amount of evidence regarding the biological danger of space radiation, even with a healthy magnetic shield. The direct effect and resulting magnetic fluctuation frequencies and electric currents induced have been shown to have significant effects on the cardiac system and on human psychology. One could argue that this is how rapid evolution occurs, but even if that's the case, the transition seems tumultuous at best, with one of the most benign periods of Earth's history potentially now on borrowed time.
Time, and how the Earth moves. Reconciling both of these things has led to some pretty strange things. Counterclockwise at about 1670 kilometers per hour. Relative to the Sun, Earth orbits counterclockwise at 108,000 kilometers per hour, along a path tilted 23.4 degrees to its spin. Within our local neighborhood of stars, our entire solar system is drifting 70,000 kilometers per hour, roughly in the direction of the bright star Vega in the constellation of Lyra. And our solar system is part of a giant galaxy called the Milky Way. On a plane tilted about 60 degrees, approximately like the windshield of a car, looking from above Earth's North Pole, our entire solar system races clockwise around the galactic center at about 792,000 kilometers per hour. Our whole galaxy is also moving through the universe, riding along in the Milky Way, in the direction that the constellations of Leo and Virgo are to us, at a speed of 2.1 million kilometers per hour, towards a thing we don't fully understand yet, simply called the Great Attractor. This is how you, on Earth's surface, are moving through the universe aboard Spaceship Earth. Okay, now stop. This is roughly 100 years of Earth's movement through space. This path we've traced, from where we began here, is the path you will take through the universe in your lifetime. You didn't buy a ticket for this ride. Your parents signed you up without asking. But nonetheless, it is quite literally
the ride of your life.
The world is like a ride at an amusement park, and when you choose to go on it, you think it's real, because that's how powerful our minds are. And the ride goes up and down and round and round. It has thrills and chills, and it's very brightly colored, and it's very loud, and it's fun for a while. Some people have been on the ride for a long time, and they begin to question, is this real, or is this just a ride? And other people have remembered, and they come back to us, and they say, hey, don't worry, don't be afraid, ever, because this is just a ride, and we kill those people. Shut him up. We have a lot invested in this ride. Shut him up. Look at my furrows of worry. Look at my big bank account and my family. Has to be real. It's just a ride. But we always kill those good guys who try and tell us that. You ever notice that? And let the demons run amok? But it doesn't matter, because it's just a ride. And we can change it anytime we want. It's only a choice. No effort, no work, no job, no savings of money. A choice right now between fear and love.
The eyes of fear want you to put bigger locks on your door, buy guns, close yourself off.
The eyes of love instead see all of us as one.
Here's what we can do to change the world right now to a better ride. Take all that money we spend on weapons and defense each year and instead spend it feeding, clothing, and educating the poor of the world.
I wonder what you would do if you had the power to dream at night any dream you wanted to dream. And you would, of course, be able to alter your time sense and slip, say, 75 years of subjective time into 8 hours of sleep. You would, I suppose, start out by fulfilling all your wishes. You could design for yourself what would be the most ecstatic life. Love affairs, banquets, dancing girls, wonderful journeys, gardens, music beyond belief. And then after a couple of months of this sort of thing at 75 years a night, you would be getting a little taste for something different. And you would move over to an adventurous dimension where there were certain dangers involved and the thrill of dealing with dangers. And you could rescue princesses from dragons and go on dangerous journeys. Make wonderful explosions and blow them up. Eventually get into contest with enemies. And after you've done that for some time, you'd think up a new wrinkle to forget that you were dreaming. so that you would think it was all for real, and to be anxious about it. And then, because it'd be so great when you woke up. And then you'd say, well, like children who dare each other on things, how far out could you get? What could you take? What dimension of being lost, of abandonment of your power, what dimension of that could you stand? You could ask yourself this because you know you'd eventually wake up. And then you
would get more and more adventurous, and you would make further and further out gambles as to what you would dream. And finally, you would dream where you are now. You would dream the dream of living the life that you are actually living today. That would be within the infinite multiplicity of choices you would have, of playing that you weren't God. Because the whole nature of the Godhead, according to this idea, is to play that he's not. So in this idea then, everybody is fundamentally the ultimate reality, not God in a politically kingly sense, but God in the sense of being
the self, the deep down basic whatever there is. And you're all that. Only you're pretending you're not. And as always, thanks for watching.